Okay, so we're learning about atoms basically. So atoms make up everything you can see, hear, touch, feel. That you can, well, yeah, it's made out of atoms. So I'm made out of atoms. You're made out of atoms. The air that I breathe is made out of atoms. The water that I drink is made out of atoms. My computer's made out of atoms. My pen is made out of atoms. Everything is made out of atoms. Now, this periodic table is essentially a table of all the different types of atoms that exist. And they all have numbers and they all have names. We have two numbers and a name, and they have a symbol. So if you just follow me a moment, we'll look at this one here. In fact, I'm not going to look at that one. I'm going to look at this one on the left. So you just follow me. Yeah, here I am. I'm on the left. I'm going to look at lithium. All right. And we're going to name some of these things on here. So first of all, actually, let's use a green. This thing here, this is what you call the symbol. Okay. That is the name of the type of atom, we can say. And this is what we call the atomic number. Now, every atom has a different atomic number. So lithium has atomic number of 3, and this lithium atom has a mass number of 7. So this is your mass number. Okay, so you've got mass number, symbol, name, atomic number. If we look at the periodic table as we start, if the very first one and the simplest atom is this one here, so you just want to make sure you keep following me, so you can see where I'm going to go. So if you click on, yeah, that's it, and then as I move around, your screen will follow me. So this one up here. So what basically, yeah, so this first one here is called hydrogen. As you can see, it's got an atomic number of 1. If we go to the next one, to the right, it's helium. It's got atomic number of 2. Then we go back to the one that we started looking at, lithium, atomic number 3, beryllium, atomic number 4. So you can see the atomic number goes up by 1. We zoom out, we can see it's 5, 6, 7, 8, 9, 10. Back to the beginning, 11, 12, and then we skip a bit, 13, 14, 15, 16, 17, 18. Okay, anyway. So the point is, the atomic number goes up by 1. Now, we're going to learn what the atomic number tells us. It tells us a little bit more than just, the fact that it's the first or the second or the third element, first, second, or third atom, period element, or whatever you want to say. But we're going to learn a little bit more about what they are. So that's just an introduction to the periodic table. Now, let's imagine that we have. You've probably seen this before. I'm going to draw a picture of a solid, liquid, and a gas. I'm going to get these atoms, and they're just going to be like this. And we're going to, because we have lots of different types of atoms, we're going to give them different colors. So first of all, just get a bunch of different atoms. In fact, I know I'm going to just I've made all this already, so give me a moment. Okay, so you've got a bunch of atoms there. What I want you to do is I want you to arrange those to be, first of all, I'm going to draw a box, and I want you to make let me just make that empty. Inside that box, I want you to arrange, let's say, maybe 6 of those atoms and make them into a solid. Okay, so draw them, see if you can arrange them into what you think they would look like in a solid. You can copy them and paste them, and there's a cool little trick you can do with Miro here. Oh, nice one. Yeah, this is much quicker. Okay, cool. Yeah, good. Okay, so let's have a look at the solid. That's a perfect picture of a solid. Now, this would be a picture of a solid if there was no gravity, which is fine. Maybe there isn't any gravity. If there was gravity, it would fall to the bottom of the container like that. If there was no gravity, it could be anywhere on this container. So, but in either case, it's a good picture of a solid. A gas is fine. This would look like if there was gravity or not. I'm going to put just another one down and the little gap there. So that's fine for a gas. The gas is the easiest one to draw. You just draw a bunch of circles. The only thing you just got to remember, they're reasonably far apart from each other, and they're not touching, and they're not in any sort of pattern. So this is not in a pattern, and they're not touching, and far away from each other. Yeah. Solid, they are touching. They're in a pattern. Liquid's the hardest one to draw. The trouble with this one is it's in a pattern, and a liquid is touching, but it's not in a pattern. So the way I think about, and this is also showing if there was gravity. It doesn't have to be gravity. So there is you can have liquid without any gravity. For example, if you're up in space and if you're an astronaut and you're drinking water, then you need to then the liquid will still behave as a liquid. So but if there is gravity, it's a little bit easier to draw. Imagine you threw a load of marbles into a container. They might not necessarily arrange themselves neatly like that, right? So if we just move a few, let's say that one falls to the bottom like that. That one goes down like that. Maybe one goes up on top of that like that. Yeah, and they're touching. We don't want to have any of them floating off. But we want to have them, yeah, exactly that. And just move this one down here somewhere. So that is basically a picture of a liquid now. That's perfect picture of a liquid. So I'm just going to, in fact, if you want to just see if you could write a little something just to the right of it on each one, what were the main things I just said about a solid, a gas, and a liquid? So why did you get 4 marks in the solid? Why did you get 4 marks in the gas? To do that, I'm just going to show you this. So I'm just at solid at the moment. So if you go up here, then if you do a star on the keyboard with Shift 8 space, it gives you a bullet point, and then you could just write something about it. So I'm going to come out of that, and I want you to use the text tool, which you can do by tapping T. Or just select it on the toolbar. That's comment. You don't really want to use comment because you want to be able to see the text. So you want to use the text tool. Okay. So the atoms are in a pattern because they're touching, but also we need to talk about how they're behaving. And what they're doing is they are vibrating about fixed points. Okay. So I'm going to just write that down. The atoms are vibrating about fixed points. I'll explain what that means in a moment. Let me just make the text a bit, not bigger, smaller. The atoms are vibrating around fixed points. What that means is that they're not staying completely still. They're vibrating, but they're not. So this, if we imagine that's the middle point there of each atom, they're kind of vibrating about that point. So they're just going, this atom is going back and forth like this. Maybe a little after a little bit, it's moving over there, then it's back here, and maybe it goes up there, goes back down here. But the point is, it vibrates about that fixed point. It doesn't really go, it doesn't go over here. Okay, it vibrates around a fixed point. Okay, so that's the movement. So then we described how they're arranged, and we also described how they're moving. So let's go to the gas now, and we're going to do talk about how they're arranged first. Okay, I'm changing the word atom to particles because, we're going to learn at some point about compounds, and in those cases, it might be that the molecules are vibrating, but we need to learn a little bit more from that. So for now, we're just going to use the word particles. The particles are touching, the particles are vibrating, the particles in the gas are not touching, the particles are vibrating around a fixed point in a solid, all that, yeah. Okay, so the particles are not touching. They spread out and they fill the container. I'm going to write a little bit about how they actually behave. The particles move very quickly and are free to separate from each other completely. Okay, so that's oh dear, let's just, there we go, that's what I'm trying to do. So that's a gas. Let's look at a liquid now. So do the same thing for a liquid. Write a couple of bullet points to say how they are arranged in a liquid. So they are still quite close, just like a solid, but they're not arranged in a pattern. So I'm going to write about how they behave. In each case, we'll write about how they behave as well. The particles are free to move by each other and but will stay as a group. So, oh no, okay. And also what I'm going to say, they do not move as quickly as in a gas. So this one, let's have a look at this one over here, for example. This could move. It's not going to go up here, but it could go over here and then move down to about here. And meanwhile, this one could go up and move over here. This one could fall down there. This one could move up to there. But they're all going to move as a. They're all going to stay together as a group. And this picture is, as I said, this is one where we're in where we have gravity, but they could still move as a group in a big ball, like on space. So I'm going to get a picture of what water would look like in space with zero gravity. I'll just get that now. So yeah, so this is a picture of water in zero gravity. It's obviously an animation because you can see it's got the planet in the background there. It looks like, but this is fairly accurate. They just go around as blobs of water, but they still stay together as a group, just like I said. Okay, so those are the three different states of matter. In other words, so matter is just basically stuff. Like everything's made out of matter. Like I'm made out of matter. My mouse is made out of matter. My computer's made out of matter. And these are the three different states that matter could be in. So matter could be in so stuff. It's like material, which is matter, could be in a solid, a liquid, or a gas. So we're going to rearrange these as well, because really we should have liquid in the middle, but we'll do that later on.